Hi, so for some time I have wanted an extensible, configurable pretty printer, and at this point I have 3 different designs for one, or more depending how you count. They all kind of suck in different ways, and I'm going to talk about how they suck. So what do I mean by this? A pretty printer prints things prettily. By extensible, I mean the implementer of the library does not need to know about all the types that can be pretty printed. So like show and pretty are classic examples of this. By configurable, I mean that the implementer of the library or the implementer of a specific instance does not decide everything about how it gets rendered. CSV and JSON are kind of examples of this. And there's a library called prettysimple, which does pretty printing based on show instances, which is also kind of an example of this. They're not as powerful as I want, so I'll say a bit more about that in a bit. I think the closest that we have right now are the type classes show1 and show2. So for example, with show1, you would say show1 on list, and this is how I want to render the elements of the list. So you get configurability in how you're rendering the elements, but you don't get any other kind of configurability. And you can also, in some cases, use new types to do this kind of thing, but there's a lot of cases where you just can't use new types, or if you can, it's like very not fun to use them. So we can take as an example the state of a chess game. This is how it would be rendered by prettysimple. And like, you know, this is fine a lot of the time, but I would like to easily be able to render it like this. So there is a bunch of information that is left out of this, and this will not always be what you want. But if it is the case that you do not care about the last moved fields of the pieces, then this will be a lot easier to read. And if, for example, you're looking at a test failure, it may be that you say, okay, like glancing at this, I can immediately see that the pieces are not where I expect them to be, which would be a lot harder to do with prettysimple. So I would like to be able to get the example on the right, but I do not want to like make that decision at compile time, or more specifically, I don't want to make that decision when I'm like deciding how to render a game state. I want to make that decision when I'm like actually rendering it. So the first solution I have requires 0 classes. And if we are implementing this solution for maybe, it will look like this. You can all probably like, yeah, I expect most people here could figure out how to write this. You've got a data type to control how it's configured. So what I'm saying is we may or may not want to show the words just or nothing. Sometimes we'd rather just show the thing if it's there and an underscore if it's not. So we've got, here is the type for configuring it, and here is the default for that configuration. This is how we do the rendering. It is, you know, there's nothing exciting here. We need to pass in a prec here is a precedence, so we know whether or not to put in parentheses in some cases, but you know, easy enough. And then if we want to render it with the default, we just call the function and call it with the default. And if we want to render it with not the default, we just change the defaults. So there are some things to like about this. It does not require any complicated features. So like if you are trying to look at the code and working out how it's done, that's not difficult at all. There are no second-class citizens in the sense that if you, like if I, the implementer, make a decision you disagree with, you just write your own function and use it exactly the same way you'd use my function. And you can render absolutely anything. So if you have a list of functions, you need to tell it how to render a function, but having told it how to render a function, you can do that. You can't do this with like show, for example. If you've got a show, if you've got a function anywhere in your like in your data structure, you just won't be able to derive show by default. The thing that really sucks about it is that for every parameterized node, at least, in your data structure, you need to tell it how to render that. So by parameterized, I mean in list A, the A is the parameterized. I can't give a default for that because like there's no way to render absolutely anything. It would just have to be a constant. And basically, anytime your data type changes, there is a very good chance you're going to need to change your renderer. So that's not going to be fun. And the functions that people implement for this are, they're not going to be internally consistent with each other. You're going to have like arguments in different orders, stuff like that. And that's going to make it awkward to use. So the next solution I have involves one class. It looks a bit like this. So again, we have the data type for how we configure maybe. But in this case, when we say how to render the element of the maybe, we put that in the data type. So we've got this renderer type, and a renderer says, oh, it's slightly cut off on the right, that's annoying. But a renderer says either you tell me exactly how to render it, or you use the GIST class itself and give me a configuration. And by using renderer, that means that we can continue to render like functions, for example. But if we are trying to render something that like has a GIST instance and has a default config itself, then we have a default config again. So we can't get a default config for list of functions, but we can get a default config for list of ints. The rendering function itself, again, nothing exciting going on there. What you would expect to do, perhaps, is to call the function gistprec and pass it the value default config. You can't really do that easily because it doesn't know which default config to use. So instead, we've got this gistprec_f function, which applies a function to the default config. So if you pass it ID, that gives you the default. And if you pass it an update, that is how you change the config. So this is still reasonably simple. Most Haskellers could probably figure out what's going on, and I like that. And compared to the previous method, if you are only changing part of your if you're changing part of your data type that you have not changed how it's configured, you probably don't need to change the renderer config. And the user can still completely override the implementer if they want. It's not as seamless as in the previous method, but it is possible. What isn't fun about it is that you have to change every occurrence of a type. So if you've got 5 places where int shows up in your data structure and you want to configure all of those, that is not going to be fun at all. The fact that we're able to render everything makes it more complicated than it would have been otherwise, which, that's, I think, probably worth it, but it annoys me. And the other thing that's really annoying is if you're rendering a complicated data structure, you're likely to have deeply nested record updates. So with the chessboard example, you have a piece inside a maybe, inside a list, inside a list, inside a board, inside a game state. So you're going to do very deep nested record updates. And sometimes you're going to do type changing record updates, which is going to be awkward with the gistprec_f stuff. And also they're not compatible with overloaded record update. So if you're going to want to use that, then things get weird. So yeah, that is that solution. The 2-class solution is way more complicated. So we, again, have the config type. And in this case, we only need to have the show constructors field, but this time it's higher-kinded, it's parameterized. In some cases, it's going to be last, and in some cases, it's going to be an identity. And we need a monoid instance, because in this case, we need to be able to say, what if the user has not supplied any config for this at all? Then we have some way to turn the last bool into an identity bool, which gives us the default value. The renderer is pretty similar again, but this time we are in a monad, and we're using extra helper functions that turn things that make things a lot more convenient. So in this case, if you're just doing the default, you provide the empty list. If you're not providing the default, you provide a list of overrides to the default. In this case, because I'm not saying configure maybe unit, I'm just saying configure maybe. So this will affect maybe unit, it'll affect maybe int, it'll affect any maybe, and you would then be able to override it if you wanted maybe int to be different. Similarly, we would be able to do config on floating, and that would be able to affect both float and double. So the nice thing about this is getting to update every occurrence of a type at once, and sometimes every occurrence of multiple types, like with floating and double. And my guess is that most of the time, that's what you want to do. And you don't have nested records. If I wanted, I would be able to say, okay, you can configure indent width, and that would be fairly easy to add to this implementation without making things horrifically more complicated. And similarly, I haven't implemented this yet, but the way it is implemented, it would be easy to add a way for the user to trace what's going on, what's getting rendered when, so that you can debug your debug code. Big downside it is wildly complicated. Trying to explain how it works to someone who is even an intermediate Haskeller might be difficult. And another big downside is you can no longer render functions. Related to the fact is that you can't completely override the implementer. So if I make a decision you disagree with, too bad. It is possible, if you only want to update the config for some ints and not others, that is possible with this. I haven't shown you how. It just requires a whole extra load of code, which isn't very fun. And if you have, if your data type changes from having an int to having a float, and you're configuring an int, you're not going to get a warning that the int config is no longer meaningful. You're just going to have be trying to configure something that's not there, and you're not going to be configuring the thing that is there. So that is a very brief overview of these three approaches that I have. Which of them, ultimately is the best? I really have no idea. That's not entirely true. I have an opinion. I don't want to tell you. I want you to tell me what your opinions are. And yeah, it would be nice to know, do people think this would be cool? Do people think exactly one of these would be cool? There are various open questions about what is and isn't possible that I can't talk about right now. But yeah, if this sounds interesting, I would love to talk about it more. Yeah, please do that. The code for it is there. There is a README. It's not the README. It's not very well polished, and the code is not very well polished. I think I've got probably a minute left. So can I have a quick show of hands? Approval voting. Vote for multiple if you want. Who thinks that the first one seems like a decent idea? Okay. Who thinks that the second one seems like a decent idea? Okay. And who thinks that the third one seems like a decent idea? Okay, thank you. So for the benefit of people not standing on the stage, that was a pretty significant number of people thought the first, fewer people thought the second, and very few people thought the third. Yeah, thank you all.